All right, so section 1, chapter 3, part 2, more about correlation. All right, correlation measures the strength and the direction of the linear relationship. And as you can see by my underline and italics, the word linear is really, really, really important right there. Okay, it measures the strength and the direction of the linear relationship. So, in other words, what we're doing now is we're going to quantify what we talked about last class with strength and direction and form. All right, the symbol for correlation is R, and it's important that you know that because the calculator is going to label your correlation number as R, and if I ask you for correlation, you need to know what to go get out of your calculator. All right, so just as some examples, okay, your correlation, your R numbers, will range always between -1 and +1. And can take on any value in between. It is impossible to have a correlation of 3 or a correlation of -1.9, all right? From -1 to +1, that's it. On picture A, we have an example of a data set that has an R value of 1, okay? The data is perfectly linear. All lines up perfect. Okay, on picture D, that is an example of a correlation of -1. Also lines up perfectly linear, but the positive and the negative on the R value indicate direction. Okay, data that is in general trending uphill has a positive R value, downhill has a negative R value. Okay, data that has no relationship, no correlation whatsoever, will have an R value of 0, like picture C. It's just this mass, no uphill, downhill, no form to it whatsoever. That would be an R value of 0. So a lot of times kids mistakenly assume that an R value of -1 or of a negative number in general is a bad thing. That is not the case. That just means that there is an inverse relationship between the variables. They're headed downhill. All right, so we've talked about +1, -1, and 0, and then you've got these numbers in between. Okay, remember that R is measuring strength as well as direction. Okay, so perfectly linear, you're going to have R values of 1. If we're deviating from that perfectly linear, then we're going to move away from 1 or -1 and more towards the zeros. So in picture B, you can tell that that data has an uphill trend. So it's still going to have a positive R value, but it's spread out from linear. On picture E, you can tell that the data has a downhill trend, but there's less spread than on B, so it's going to be closer to -1. Okay, so more spread out, closer to 0. Tighter in linear, you're going to be closer to either positive or -1. Okay. And speaking of closer to linear, okay, if we look at picture F, that hopefully, obviously, is not linear data. That data is parabolic. And R only measures the strength of the linear relationship. So if you have data that is parabolic, you're going to most likely have a set of data that will have a correlation of 0. So, before we do this, let's play with yesterday's data with boats and manatees. Okay, should have told you on Monday to keep this in your calculator, but I totally forgot. So if you still have it in your calculator, yay. If you don't have it in your calculator, pull out your notes from Monday and put the data in the calculator again, and Mr. Cox will pause this video while you accomplish that task. All right, so assuming that everybody has the data back in their calculators again, Okay, let's look at the scatter plot again of the boats and manatees. So we want boats here on the x-axis, and we want manatees on the y-axis. So, talk amongst yourselves. If you were going to make a guesstimate of what you think the R value is for this data, what do you think it'll be? Mr. Cox, you can write their guesses on the board, and I don't know, I'll give somebody a lollipop and we get back for whoever's closest to the R number. Go. Okay, hopefully Mr. Cox has those numbers written down. Okay, to get your calculator to give you the actual, for real, legitimate R number, you're going to go to Control, Menu. Okay, I lied. It's so not Control Menu. You are going to open a calculator page. Sorry, it's really late. It's 6:30 and I need to go home. All right, so you're going to open a calculator page and hit Menu, Statistics, Stat Calculations, and then you want one of the linear regressions. I don't care which one, pick whichever one floats your boat. Let's go with number 3 for today. And then we're going to tell it that the X's are boats and the Y's are manatees, and you're going to hit OK. And as you look down to the last number on the list, we have R equals 0.9529 or 0.953 if we round. Whoops, wrong one. That number right there. Okay, so that's our correlation. Pretty tight, pretty linear, uphill, which we knew. So 0.953. Now, things to know about correlation. Okay, when you calculate an R number, your calculator is not making a distinction between the explanatory and the response variables. It doesn't matter in terms of correlation which one you put where. If you flipped those variables around and put manatees on the X and boats on the Y, you would get the exact same R value regardless of which one went where. Okay, number 2, units of measurement don't matter. Okay, if we had data on height and weight that was in inches and pounds, and we then converted the data to meters and kilograms, both sets of data would have the same correlation. Doesn't matter if you convert the units, it'll still be the same. And R does not carry a unit of measurement. Okay, it's not a 0.953 manatees or a 0.953 inches. There's no unit assigned to the R. One of the most important things that you need to get out of this list is correlation does not mean causation. Just because there's a correlation or an association between two variables does not ever mean that one thing causes the other. And we're going to talk a whole lot about that when we do the chapter on design of experiments. Number 4, variables must be quantitative. They must be numbers. You have to be able to get them on a scatter plot. Okay, it does not make any sense to say that that there's a high correlation between people who have brown hair and IQ. Brown hair is not a quantitative variable. It's got to be quantitative, numerical. Number 5, your R value only measures the linear strength of the relationship. Okay, so if you have data that's parabolic and you pull an R number on it, it is meaningless. And number 6, if you've got an outlier in your scatter plot, that will have a huge effect on your R value. So you need to decide if you're going to dump outliers from your data set or why they're outliers in the data set. and then decide whether you're going to include them or not before you pull the R value, and hopefully make an intelligent decision about whether you're going to leave that R value in or pull it out. All right, have fun, get some work done. See you guys on Friday. Bye.